Assalamualaikum warahmatullahi wabarakatuh. This is part 2 video for chapter 6, data design. In this video, we will cover database management systems, components, and a few other objectives such as web-based database design, data design terminology, and data relationship. Okay. So the other four topics, four objectives here, we will cover in the third video. Okay, basically in part 1 video, we have covered data design concept, right? So DBMS basically referring to database management system, which is a collection of tools, features, and interfaces that enables user to add, update, manage, access, and analyze the contents of a database. For example, Microsoft Access, MySQL, etc. So before constructing an information system, a system analyst must understand basic design concept. So you have learned this in the first video, right? Okay, now DBMS component. Okay, a DBMS provide an interface between a database and users who need to access the data. Okay, so system analysts must understand all of the components of DBMS. Okay, this diagram shows that in addition to interfaces, a DBMS also has a data manipulation language, schema and subschemas, and a physical data repository. So user typically work with queries, and database administrator, which is DBA, is responsible for DBMS management and support. And DBMS also can support several related information systems that provide input to and require specific data from DBMS. Okay, so these are the components of DBMS that a system analyst must know, right? Okay, as described in a previous slide, okay, user involved with query language, query by example, and structured query language. And database administrator, DBA, is responsible for DBS management support system. Okay, related information systems. DBMS can support several related information systems that provide input to and require specific data from the DBMS. Right? This is unlike a user interface. Okay, this is two-way communication between the DBMS and the related systems with no human intervention required. Okay, next, data manipulation language. Used to control database operations, including storing, retrieving, updating, and deleting data. So most commercial DBMS that use a data manipulation language such as Oracle and IBM's DB2. But some database product such as Microsoft Access, they are using menu-driven commands that enables users to control the operation. All right. Okay. Next is a schema. Schema is a definition of a database, including descriptions of all fields, table, and relationships. Okay. You also can define one or more subschemas. Okay, actually, subschemas are used to define only those portions of the database that a particular system allowed to access. For example, to protect individual privacy, you might want to allow a project management system to retrieve employee pay rates. Okay. Okay, in that case, the project management system subschema would not include the pay rate field. Okay, next is a physical data repository. Okay, if you remember, in chapter 4, you learned about data dictionary. Chapter 4 is enterprise modeling. Okay, Data dictionary actually describes all data elements included in the logical design. Logical design means it's on paper or documented. So at this stage, which is data design, data dictionary is transformed into a physical data repository, meaning that you are now have to key in all data dictionary described in the previous phase into a physical form. Okay, which means now you have to key in into a Microsoft Access. Okay, for example, if the Microsoft Access your database, the physical repository might be centralized or it might be distributed at several locations. Okay, this is depends on your database platform use, right? Okay, web-based database design. Actually, the concept of a web-based system was discussed in chapter 5, development strategies. Okay, so in this chapter 6, you will revisit this concept and examine the main components of a web-based database system. Okay, these are the characteristics of web-based design, which is the internet serves as the front end or interface for the database management system, and internet technology provides enormous power and flexibility. Okay, web-based systems are popular because they offer ease of access, cost effectiveness, and worldwide connectivity. Right. So the internet terminology is a web browser, web page, HTML, web server, website, and intranet. Uh, all these terms use I think very familiar to you. Extranet, protocols, web-centric, clients, and servers. Extranet is an extension of a company intranet that allows access by external users. Protocol is basically a data transmission standards, and the internet sometimes called web-centric. Okay? Connecting a database to the web. Okay, in order to access data in a web-based system, the database must be connected to internet or intranet, right? However, the database and the internet speak two different languages. Okay, for example, HTML used to allow you to view a page in the web, right? Okay, for database, they are created and managed by using various languages and commands that have nothing to do with HTML. So, in order for you to connect to the database through the web and enable data to be viewed and updated, you need a software that integrates different applications and allows them to exchange data, uh, which is called middleware. Yeah? So middleware basically interpret client requests in HTML form and translate the request into commands that the database can execute, right? A popular example of middleware is Macromedia called Fusion. Data security. Web-based data must be secure yet easily accessible to authorized user. Okay, so in order to achieve this goal, um, well-designed systems provide security at three levels, which are database itself, the web server, and the telecommunication links that connects the components of the system. Okay, I think that's all for the web database design, and the code for this video is 4918. Okay, now we move to data design terminology, right? Basically, using the concepts discussed in the previous sections, you as a system analyst now supposed to have in your mind which approach that suits your system development. Okay, for example, you have to choose either to use a file-based system or database system or web-based database, right? Okay, after decide the approach that you are going to use, then you can start to construct the system. And the first step is to understand the design terminology, the data design terminology. So, data design terms include entity, table, file, field, record, tuple, and key field. Okay. Entity is a person, place, thing, or event for which data is collected and maintained. Okay, for example, uh, an online sales system, okay, may include entities named customer, order, product, or supplier. Okay, next is a field, which is also called attribute. Is a single characteristic or fact about an entity. For example, a customer entity might include the customer ID, first name, last name, address, and so on and so forth. Okay, common field is an attribute that appears in more than one entity. So common field can be used to link entities in various type of relationship. Okay, so record, also called tuple, which is a set of related fields that describes one instance or occurrence of an entity, such as one customer, one order, or one product. And record might have one or dozens of fields. It is depending on what information is needed. Okay, this is the example of table or file of the database. Okay, key fields. It is to organize, access, and maintain data structures during system design phase, right? There are four types of keys, which are primary key, candidate key, foreign key, and secondary key. Okay, a primary key is a field or combination of fields that uniquely and minimally identifies a particular member of an entity. For example, in a customer table, you have a customer number which is unique, which is no two customer can have the same customer number. So the customer number is a primary key for this case. Okay, there are four types of primary key, which are combination key, composite key, concatenated key, and multi-valued key. Okay, any field that could serve as a primary key is called a candidate key. For example, if every employee has a unique employee number, then you could use either the employee number or the social security number as a primary key, right? So any field that is not a primary key or a candidate key is called non-key field. Okay, foreign key is a common field exists in more than one table and can be used to form a relationship or link between the tables. This is, for example, student ID field. It can be appear in a student table and the course table. Okay, student ID for sure is a primary key for student table, and it might be a foreign key in course table. Okay, secondary key is a field or combination of fields that can be used to access or retrieve records. Basically, secondary key values are not unique. Okay, for example, postcode. If you need to access a record for only those customers in a specific postcode, you will use a postcode field as a secondary key. So secondary keys also can be used to sort or display orders in a certain orders. Right? Okay, referential integrity. It is a type of validity check which can help avoid data input errors. Okay, validity check is a set of rules that avoids data inconsistency and quality problems. Okay, in relational database, Referential integrity means that a foreign key value cannot be entered in one table unless it match an existing primary key in another table. Okay. For example, referential integrity would prevent you from entering a customer order in an order table unless that customer already exists in the customer table, right? So I think that's all about the validity check, and this slide should be the end of this video. So in the third video, we are going to cover data relationships. Okay. So data relationships will discuss about logical link between entities based on how they interact. Okay. You are going to learn about entity relationships diagrams, uh, which involves three types of relationships: one-to-one relationships, one-to-many relationships, and many-to-many relationships. Okay. You also will learn about cardinality, which describe the numeric relationship between two entities, and learn how to model the interaction by adding cardinality notation, Crowdfoot's notation, and use unified modeling language. Okay, so I think that's all for now. See you in the next video, right? Assalamualaikum warahmatullahi wabarakatuh. Thank you.